This week we're going to talk about securing and managing network services and data. When we run services that are available on the network, sometimes we want to restrict the access to these services to certain individuals or certain networks. And there are several ways to do this. TCP wrappers is one way. TCP wrappers basically allow you to restrict access to a service, and you could do this by the network or by the domain they come from or different other ways. Um, to figure out if the service that you're running has support for TCP wrappers, you just have to make sure that that service has been compiled against the libwrap library. And to find out if it has TCP wrapper support, you could use the LDD command. So LDD basically tells you what libraries a particular executable has been compiled against. So we want to do LDD, then we want to pick the service. So let's check Apache and see if Apache has TCP wrapper support. So user has been HTTPD. Then we're going to pipe grep lib wrap. Okay, so it looks like Apache does not have support. Now let's try SSH. User has been SSHD pipe grep lib wrap. See, as you can see, SSH does have support for libwrap. Now let's try the FTP service, which is BSFTPD. It also has. So both of these services have TCP wrapper support where Apache doesn't. Okay, so how do you control this? How do you restrict or allow access to the service? Basically, you do this with two files, the etc host.allow and the etc host.deny. Let's take a look at the allow file. pi etc host.allow. In here, you basically list the service and then who is allowed to access the service. So for example, here I'm saying that for the SSHD service, which we already know has libwrap support and is capable of being used with TCP wrappers, we want to allow this host to access it. Okay. For the telnet D service, we want hosts in the csc570e.edu domain to access it. Then for the service BSFTPD, which is our FTP service, we want hosts in the csc570e.edu domain to access it, except for, and then here really we should use a host name. So we could do except for let's see, ftp.csc570e.edu. So basically anybody in this domain can access it except for this particular host. Okay, so again, the host.allow is the file that tells you who can access the service. Okay, now let's take a look at the deny file. Save that. Host.deny. Now in here, this is who we want to deny access to. Okay, so here instead of specifying one service, I'm denying access to all the services. So I'm saying for all services, I'm denying access to everybody or all. And also I'm using this message here so that my log, when basically this twist command here says to echo this to the user. So the user, when they try to connect to any service here that they can't access, they will get this message that says only this host is allowed access. And this will also be stored in the var log syslog, var log messages syslog file. Okay, so here's the things that you need to know. The allow file, the host.allow file, it takes precedence because when TCP wrappers evaluate things, it goes through the host.allow first and then the host.deny. And then order matters because the first rule that applies is the one that gets used. So if one rule applies for you, then it gets used and it goes with that no matter what the other rules say. So if something in the allow file says that you can use the service, then you will go ahead and use the service. Um, but there are several ways of doing this. What I have done is I have denied everybody on the host deny for my services, and then on the allow, I just allow access to the ones that I want to allow it to. That way I deny everybody here, and then anybody on the allow are my special users that I want to allow. So that's one way to configure this. So that's basically your TCP wrappers. Um, Another tool that you can use to protect your services is the XINET-D. If we go to ctc cd etc xinetd.d, we can see this is the directory where basically XINET-D is a service that replaces the old INET-D service, which was a service in the Unix world that allow you to run other services under one particular service. And INET-D had some issues, and XINET-D is a little bit more secure, and it allows you to not only run different services under the XINET-D process, but it also allows you to run those services under a different username than root, where INET-D only allow you to run those as root. With XINET-D, you can actually configure those to run as other users. So let's take a look here. If we look in this file, anytime you want to add another service to be run under the XINET-D process, you would just add an entry here. So let's take a look at one. Let's say you wanted to run Telnet on this machine, which is basically like SSH but not encrypted. If you ran Telnet on your machine, you would go here to the etc xinet.d directory. You would vi the KRB5 telnet, which is a Kerberos 5 telnet, and all you would have to do is edit this disable and make it equal to no, so it's not disabled. And then basically here it tells it that this is the telnet process to run it as the use root, and it's to use a stream here. So those are basically the parameters that you set, and then you press escape and you save it. And then if you restart the XINET-D, so if you do service XINET-D restart, we do that, then we do a netstat minus netp pipe grep 23. We can see that now Telnet is listening on port 23, but the process is actually the XINET process. Okay, so it doesn't run under its own, it runs as XINET-D. So I'm gonna disable Telnet, so I'm gonna go back here, make this equal to yes, save it, restart it, run the netstat command again. Now it's not running anymore. So that's one of the nice things about XINET-D, is that it allows you to run other services as the XINET-D process, and it allows you to secure those services so that you don't have multiple processes out there. Instead, one controls all of those. And again, it improves the security of INET-D, and it allows you to run each of your services as a different user. One thing I forgot to mention about the wrappers, the TCP wrappers, is I wanted to test that. So let's take a look again. I never tested TCP wrappers, so let's test TCP wrappers. So let's look at more etc hosts that allow and more etc hosts that deny. Okay, so I'm denying everybody for SSHD except this host. So if I SSH from here locally to this machine, it should not work. So let's try it. SSH localhost. See, it tells me connection removed by host. And SSH is one of the processes that it actually doesn't echo this, but Telnet will. So let me again edit that xinetd Kirby file. No, I'm gonna restart. I'm gonna restart Telnet under xinetd, and now I'm gonna Telnet localhost. See, in this case, it tried a Telnet, but TCP wrappers disabled it, disallowed it, and it echoed me that message that I had. So that's because of this rule here. Okay. And the allow, the only ones that were allowed were hosts in the .csc570e.edu domain, and since I connected from localhost, I'm not in that there, so it goes to this rule here, and then I get this echo to me. So that's how you test that. Okay. Now let's talk about SSH. SSH is basically a process that replaces the old Telnet process and the FTP process, which were protocols used in the past to have access to the terminal and run commands. But the problem with Telnet was that it was not encrypted. So Telnet was all in the clear. Same with FTP. When you wanted to get a file, it's all done in the clear and it's not very secure. Now, Telnet, OpenSSH basically secures both of those protocols. So let's take a look at how you configure SSH. The main configuration files for SSH are under etc/ssh, and for the server, the file is sshd-config. Now, let me quickly take a look at this file and show you some of the things that you need to check for on this file. SSH runs on port 22, so that's important. And then there are several things here that you might want to configure. First, there are several ways to log into SSH. You could do this by putting a password, or you could do it by using private and public keys. Okay, so depending on how you want to do that, you could configure it here. Then you could also configure how you want to log in your information to the syslog. Now here's an important one: permit root login. This is if you want to permit root users to log in here. One of the things you could do is that you could permit root login only to if the user uses a key, so that way the root password never gets typed. So there's a way to configure this like that. By default is commented, so it's no. So here's some other see, here's where it allows password authentication. A lot of people disable that and only use key authentication because it's a little bit more secure. Okay. And then one of the nice things about SSH is that it allows you to forward X11 connection. So if I was running X Windows on this machine and I SSH to another machine, I could run a command there and it would actually display on my machine. And that's called X11 forwarding, the ability to forward a process with graphics from another machine into your local machine as if it was your local machine. So that's one of the nice features about SSH, that it allows you to do that. But of course you have to set that here. Okay, so that's basically it. Here you could do a banner just like we did with FTP. You could put a banner that basically says welcome to SSH, whatever you want to put there. On the client side, here we're telling SSH to use SFTP as well to allow users to run the SFTP command. So from the client side, there are several ways to connect to an SSH server. You could do SSH and then localhost, and this basically is like doing a telnet to the local host. It connects to the machine. Okay, here we have it disabled through the wrapper, so it won't connect, but that's how you would connect. We could do that to the NS server, csc57e.edu. See, and it will connect. See, here it's asking me for a password because my key that I have locally is not trusted by the ns.csc57e.edu machine. But in our case, at the beginning of the semester, I had you trust my key so that I can connect to your virtual machines and grade your assignments. So that's what we've done there. Now, SFTP is basically an FTP that is secure, that is encrypted. And you could just run the command SFTP ns.csc57e.edu. And that connects me there, and then from there on, I can list the files and I can do a get mbr.img if I wanted to get it, or put if I want to put a file, just like the FTP, the regular FTP protocol, but in this case it's secure. Now another client tool that you can use is SCP. SCP allows you to send a file to a machine, so you could do SCP, let's see what kind of files, SCP SSH host key to root at ns.csc570e.edu, and then you colon, then you put the directory. So I want to put in the temp. So if you did that, it will prompt you for a password, and then you can put the password and it would actually send the file. So it's a secure copy, a way to securely copy a file. Now let's see, one of the things that you want to do with SSH is, like I said, try not to use passwords, instead to use keys to make things more secure. So when you want to do that, you have to create your own set of private and public keys, and to do that you use the tool, the command SSH keygen, and then you tell it the type of key that you want to create. In my case, I want an RSA key, which is a more secure key. So I want to do that. Then it's going to create a pair, and it's telling me where to store it. By default, it puts it in the .ssh directory, which is fine. Do I want to overwrite? In my case, I don't want to overwrite it because I already have one. But what this does is, if you go to your .ssh directory, if I didn't have this already, I would say no, and they would ask me for a passphrase, and you could leave that blank if you want to, or you could put a password too. But basically what it does is it creates two keys. One, your public key, which is this one here, more ID, okay, and then your private key, which is the ID RSA, okay. So this is your private key. This you keep to yourself and don't give to anybody. Okay, and if you put a passphrase, it will prompt you for the passphrase every time you use it. Now your public key you give to users that want to access your OpenSSH server, and they need to put it in their authorized keys file. So they need to insert that there. Once they do that, if you connect to their machine, then you will be allowed access because they're saying they trust your public key. Okay, so that's how that works. The last topic that I want to cover is SE Linux, which is Security Enhanced Linux. And all of this is a mandatory set of access controls for Linux. And it's a way to secure processes and files in Linux. SE Linux is a very, very complex topic, but the only thing I want you to know at this time is just that the files to configure SE Linux are in etc SE Linux, and the config file is the basic file that you want to configure. Things to note here is that Red Hat 4 has this particular policy that is called targeted, which affects basically 12 different applications and their domains. And some of the application it affects are the DHCP, which you've used, the Apache HTTPD, the name service, and the syslog services, among others. And with SE Linux, basically you can protect these services so that if a user is able to find a hole with those particular services, then they don't have all the permissions that the user that the service is running as has. So when we install Red Hat, we disable SE Linux. And here what I've done is basically I've set it to permissive, which just prints the warnings at this point. Okay, if you wanted to secure things even more, you could actually enforce it by putting enforcing. Anytime you make changes to this file, you actually have to restart your machine. Okay, so what I've done is I want the targeted policy, and I just want a permissive set of controls. Another way to configure this, if you want to do it from the GUI side, is to run the system config security level utility, and you have to run this from run level 5 with graphics in order to use that tool. SE Linux, like I said, is very daunting, very difficult concept to understand, but all it does is it gives you better security for all services that you're running there in case they're compromised by a hacker.